Hey guys, getting ready to just do some basic car building here. One of our Viper chassis. I'll go ahead and put the guide pin in it, some electrical parts, and if my phone will cooperate, maybe do some magnet fitting on the bottom of the chassis, kind of show you guys what's important, what to look for, and maybe somebody will learn something from this video. So I got my parts here, my little container here. I got basically independent front end, some guide pins, pickup springs, and other electrical components. And go ahead and start out with the guide pin. So if I can find one in here, let's see. Here we go. So for this particular build, I'm going to be using an extended hardened guide pin. I'm not sure if it doesn't look like my phone wants to cooperate and zoom in on that, but it's a little bit different than our standard guide pin. I always just set it there. It's just literally sitting here right now. I have these pliers here. They're flat. They have no teeth on them. And I'll go ahead and I'll hold it sideways just like this. And I'll push it in once. And then you could actually leave it in that position. I always run it to the back just because I like to have it underneath the axle. And I always run short wheelbase for the majority of the builds that we do. You might find that moving that around makes a difference, but for your application. But right here I just grab the front of the guide pin and I put the pliers on the back of the chassis here. Push it in the rest of the way, and now that guide pin is seated and ready to go. We'll go ahead and repeat that on this other one. If you guys have any questions while you're watching, I'll do my best to answer them. So you can hear how crisp that pops in there. That one's in. Now, you can, I've seen guys do all kinds of different processes on putting this in. This video doesn't mean this is the only way to put it in, obviously. This is just what works for me. And I apologize if it's video. Sean asked what guide pin's that. That's an extended guide pin that's been hardened. I usually use them when I do custom builds. Both of these cars that I'm going to be doing right now are they're Pro Super Stocks, built to Hopra specs, and I use it just kind of as a safety over the regular guide pin. The regular guide pins, they're not super hard, but these ones, I've had a lot of good luck with them, and they work really good for me. So the next thing that we're going to do is we're going to put our hangers on. I'll go ahead and I'll grab these with tweezers so that maybe you guys can see them a little bit better here. This is a pickup hanger, and I don't do anything to these things. I never bend them. I don't tweak them. I literally, they come right out of bulk stock, right off of the punch like this. If I guess some of the old school stuff, you would bend this hinge point back here to try to keep the car from what we call heeling, or try to just pull the back of the pickup shoe up into the chassis more. And I run my cars sometimes super stocks down in 325 on the front tire diameter, and I still don't bend this guy back. When you start bending that, you alter the way that the pickup shoe functions. And to be able to build cars consistently, and unless you have some kind of a fixture for bending that where you can do it the same every time, once you find a bend that works for you, I would recommend just putting them straight in. So you pro racers out there, you guys obviously you have your ways of doing it, and you know, I'd love to hear what you guys do, and maybe together we can, you know, we can make something better. But for the most part, I don't do anything, and I go ahead and just push it in here, and you can see that it wants to go in a little bit sideways, and that's because once it's seated, it will, the bottom corner down here, it'll actually pop into place. And so once that pops into place, now it's nice and square and sitting the way that you want it to sit, nice and flat on the bottom. All of these things, you know, they all equate to having a really good, well-balanced car. You definitely don't want the rail hitting back here and having the pickup shoe just kind of floating around on the front there. This will if it's heeling, you at least want it to be the same on both sides. That's why, you know, we try not to bend these, because if you bend one more than the other, not only are you going to change the way that the shoe pivots, but you're also going to, you could alter the spring tension, because you're going to be compressing the spring more or less than the opposite side. So having it neutral right off of the, or out of the package, is going to be the most consistent and repeatable way to build one of these cars. And that's what we go for here, is we try to build them consistent. You can see these things, when there's no spring or end bell in them, they just float around on there. They're just held in by pressure, but they won't pop out. So next thing I'll do is I'll flip the cars over, and I have some 8th thou springs here. I'm going to go ahead and drop some 8th thou springs in there. I typically run 8th thous on super stocks. There's all kinds of options for the springs, but that could be another video someday. But there is a lot to the springs. There's a lot to the way the car handles, how much power it has, and even how it crashes. The springs can have an effect on that. So you can see, well, kind of see here, if we can focus. But I'm going to move this stuff out of the way just to see if we can get this thing to focus up better here. So come on, focus up here. Well, next thing we're going to do is go ahead and put our shoes in. Now, this is something that there's 100 ways to do this, and I'm only going to show you the way that I found works the best for me. It gives me the most consistent way of installing the shoe, and also keeping the shoe as flat as possible. When these things are punched or stamped out, it's a multi-stage process, and they're very, very flat right out of the package. You definitely don't want to bend these shoes or tweak the shoes. You know, I mean, I wouldn't tweak them at all. I would do nothing but put them in. And so what we're going to do here is, the shoe right now is just laying, it's just laying on here, okay? And all we're going to do is we're going to push the back down. I wish this thing would focus for me. We're going to just push the back down, and it pops right in, okay? We didn't flex anything. We did put pressure on it to get the back to drop down in there, but we didn't do anything more. You know, we didn't. One thing I definitely don't do is I don't hook it and then push it down on here. I mean, that's a great way to create a lot of shoe problems for yourself, and where you're going to be playing catch up from the start, because you're going to, if you bend that shoe and tweak that thing, just installing it, then you're going to be fiddling around with it to just get it back to the state that it was before you installed it. And I don't know about you, but my time's valuable, and I don't want to waste my time doing that. So that being said, put the front of the shoe down first. We just slide the back in. It pops right in there. Super easy. Okay. So now this chassis is now ready for a motor to be installed into it. Okay. So when we build these here at the factory, the production cars, we'll build them to this point, and this one's been pinned already. But we will build them to this point, and we call this a sub-assembly. We'll have a bunch of these sub-assemblies set up, and then we'll go back and we have motor sub-assemblies, which I have already built here. This is a super stock motor setup, which is ready to drop into the car. This one, it's all pre-seated and a bunch of stuff that's basically for another video. Quick question here. Jim Keen asked if I ever restrict the travel of the front of the shoe. I do not do that on these cars. I know guys do that on T-Jets, and I mean, you could do it, but I haven't really seen a reason for what I'm doing to do that. I mean, I really try not to alter anything that's been done there. All of the engineering work, all of the modeling that's been done on this electrical system and the function of it, if it's altered, it changes all of that. And so, I mean, usually these cars, when you run a low profile shoe, I don't know if you can see, but there's not a lot of travel there to begin with. It's nowhere near what a stock Super G Plus would be. Let's see, and Roger says he uses the tweezers to fit the shoe over the front. So I would imagine that he just uses the tweezers to aid in getting that shoe over the front, so that he's not putting pressure along this face, which is the important face. So that definitely will work. Good tip, Roger. So let's go ahead and shoe up this other side here. Okay. There's one. There's the other. Okay, and you'll see that it's kind of, you know, it still moves around quite a bit, and that's just because the end bell's not in there. Once the end bell's in there, it's going to force this thing forward, and it will stand it up, and it'll be in its final position. But you can check how that's going to go just by pushing tension onto the hanger, and you can feel the springs. Once we put a motor in there, I'll look across it, and you can even look right now, and I'll try to look across. Like right now, the way I'm holding it, even though it's blurry, is they're completely symmetrical, meaning that one shoe is not tweaked forward or backwards, and that's extremely important when you are building these things. You want everything to be as consistent as possible. I mean, even if one's lower than the other, you would rather have them both low or both high than having one different than the other, because that's going to give you inconsistent spring tension. So the next thing that we usually do on these guys, if these were production cars, is that we would go ahead and throw a razor front end in them. Today on these ones, I'm going to be using the Wizard independent front ends, which need to do some chamfering on the, I'll go ahead and move these chassis and show you guys here. But these axles, they're just cut off with the saw, and I usually just will put a little chamfer, so I'm spinning that in my hand as I touch it down on this grinding stone. That just puts a little 45 on it, allows the retainer to go on easier. It doesn't cut the retainer. A lot of times if you've assembled these front ends, you'll put them together and you'll have a big old burr sticking out, and that burr is because that sharp edge has cut through, and we want to try to keep the retainers as tight as possible on there. So I'm going to go ahead and grab a little setup block here. I'm going to use this as so I can tap these guys on here. So this is something, when I put one of these independent fronts together, okay, I usually will install the retainer inside the front wheel, and then I put that down just like that. Man, and this thing is just, I am still live here, Michael Lane Brundage. So I'll put it down like that, The reason that I do that is because it's much easier to go ahead and tap this guy on there. I'm going to just use the back of one of my RC tools here. So now that's seated. It's all the way flush. Once again, I apologize for it being blurry. I'll go ahead and do that to this other one. So we're going to take the front wheel. These retainers, you can't see it, but they have a very small flat on them that I usually put. There's a thin and a thick side, and I usually put the thin side in, and then I'm going to go ahead and tap this guy back in there. Now, there's all kinds of tools you can use for this. I usually use a small brass hammer, but right now I don't have it on my desk. So, here you go. See, Roger's got some tips for the black retainers here. I'm going to go ahead and install this in short wheelbase. I'm going to slide a rim on just to see how much extra axle we have sticking out, because so you can see there's quite a bit of axle sticking out there. So I definitely want to space this front end. And before I do that, I want to make sure that everything feels nice and free. You want that axle to float through there. Even though this is an independent front end setup, you still want that axle to be nice and free. So you go ahead and get this out of the way. We'll get this other one set up. Okay, we'll make sure that this one's nice and free. Okay, there's something important here. We've made sure that when we made our chassis mold that you don't have to do anything to this front axle hole. So it's super free. There's no burrs. There's no flashing on the inside here, which I don't want guys to have to ream anything. I want guys to be able to just put these things together and have a really good car right off the bat. So Roger says rough up the front of the axle where the retainer will sit, and use a little green Loctite sleeve retainer. And because these guys, from cornering pressure, this rim is pushing on that thing in compression molded polymer modified, which is the Hopra modified class that we run, and that's a national class. It will actually start to force that retainer off of there. And so what he does is he roughs that surface so that it gives a Loctite something to hold on to, and then he also Loctites it on. Now you want to be careful when you Loctite that you don't Loctite your independent wheel on there. So just be cautious when you do that. So let's see here. I'm going to get some spacers out, and we'll start spacing this guy. And Roger said that's why guys lose front axles. You definitely don't want to lose a front axle. That's not good. You will instantly slam the front end of the car down and start running hot, start having really bad shoe wear, and just overall, do whatever you can to keep those retainers on there. So right now I'm putting 2 10,000ths thick Viper stainless spacers on here, and we're going to see where this gets us. So it looks like we're just a little bit shy still. I'm going to get out my my calipers here. Sean says he's been there, done that. So we'll go ahead and measure this. The maximum width allowed for Hopra racing is 1 inch 3125. And so right now we're at 1 inch 288. So we're quite a bit small. One thing though is you have to be careful, because sometimes these axles are a little bit undersized on the width, and ideally you would want the axle to be on one of these particular front ends. You would want the axle to be right there. 1 inch 310 is what I would probably shoot for. And the reason for that is then you could press the retainers on all the way on each side, and then space the car so that there's just a little bit, maybe Depends on how much play. Routed tracks, I found that they want different amounts of play than, like, to be fast on a Tomy track, for instance. I almost always run more side-to-side slop, and that's just to let the car track better, more natural down the straightaways, because the sectionals aren't as perfectly straight. So now we're at 1 inch 294, but I can definitely tell that my axle is shorter than that. So I'm going to go ahead and on this one, I think I'll probably put about 5 thou on each side of it and call it good. So let me get my 5s out here. Looks like Jerome's watching. How's it going, Jerome? So these are 5 thou spacers. Anytime I run thin spacers, or just any spacers in general, I guess you could say, when they're different sizes, I will always put the thinner spacers to the inside. That's really more evident, I guess, on the rear axle setups, just because you're changing them out more often, and you don't want to have a thin spacer out there and then collapse that spacer or fold it over, and then your gear mesh and everything, it's way too tight, or your axle setup's too tight, and you're gonna be burning up a motor like Sean did at the Nats. Let's see here. All right, and the other thing, hey Rich May's watching. So the other thing too is, this is a tight measurement here. So 1 inch 303 is tight, okay? But we want to leave this thing just a little bit loose when we assemble it. So it will tech, but it will still have a little bit of float. So let's see here. Let's get our other retainer. And this one, what I do is I'll actually raise the rim up so that I can drop the retainer in. Okay. And then I'll go ahead and tap that whole setup down in there. Now you could use a press, I'm sure, and this guy is a little bit tight right now, so I'm gonna grab one of my presses. Let's see, be back in 1 second. Don says, you guys run front axles? We try to keep them in, that's for sure. Alright, so we're going to go ahead and get this guy. Whoops, wrong press. Let's see, I've been cleaning stuff up here, so my tools are a little bit misplaced. Usually my tools are in my big wooden slot car box, but I don't really use that box anymore. I'm trying to use a little bit less space on my office desk here, because my office desk doubles as my desk and build bench, so bear with me. All right. Yeah, Sean says all 4 tires must touch the track. Definitely. I gotta find out if anybody knows how to make it to where it's not as blurry. I'd love to know. It does seem like it doesn't focus very well, but maybe that's just because we're doing this on my cell phone here, so. Alright, so we're back here. So I went ahead and loosen these up just a smidge. And Nathaniel Martin asked if I ream the holes. Earlier in the video I stated that we spent a lot of time making sure that when we molded the chassis that we would do that in a way that made it so that you didn't have to ream the holes. You don't have to do any of that stuff. It's all just drop it in and go from there. So that setup's good. We can go ahead and put our front tires on, and then that will be pretty much it for this video. Front tires, so this is a Wizard front tire. I believe these are 335s. That's kind of what I usually put on like a customer build. Oops. Looks like I lost the spring out of that one. I just popped that guy off. But I usually run a 335 on customer builds just because that's a pretty good starting point for the most part. There's a couple of things after I get these on that I'd like to show you guys before we end this video. One of them, when you put the tire on, I always put my fingernail right down in here, and I put my fingernail down in between the rim and the tire, and I rotate the tire, because you want these tires to spin as true as possible. You don't want any wiggle in them. More times than not, when you have a loud car, it's almost always the front tires, or you have a bent axle. It sounds like a train. It's not supposed to. It should be very, very quiet. That's one thing with the Razor front ends that we like. You know, the Razor front ends are really, really quiet and smooth. They're really easy to put together. And you know, we look forward to bringing out our own independent front end here. Probably won't be out by the end of this year, but it'll definitely be out the beginning of next year. So JJ, yeah, this is a Wizard front end. Wizard. This one has Delrin front rims, one of their drill blank axles, and then it has the Viper spacers on it. But for the most part, that's the beginning of the car, and we'll probably do another video. So Roger says his favorite front's the Wizard aluminum narrow. I would definitely agree with him on that. You can't go wrong running the aluminum ones. They're really, really tough. I've never seen one of them bend or break, whereas these plastic ones, you know, if you hit them hard enough, they can bust the flange off of them, but they are super light, and with everything, you know, lightweight. There's always a pro and con of everything.